Okay, so just wanted to talk about some of the things I noticed in the forms that were turned in and the work that we did in class today. Now we are still using function notation. You should be getting used to seeing the g of x, the f of x, h of x, j of x. Doesn't really matter the letter in front of it, but it's called function notation that x is always going to be our input, then g of x or f of x would be our output. So now we wanted to find g of 10. So wherever I see x in my g function, I would plug in 10, and you get g of 10 is equal to negative 29. Part of the reason I wanted to show you is look at how I show my work. Notice that I continually show g of 10, so that when I get at the end, when I have my end result here, this is really saying when my x coordinate is 10, my y coordinate is negative 29. When I put 10 through this function machine, 10 is my input, my output is negative 29. So that's all that information is shown in that answer. I just put some of the answers for the next one. What I did notice, so when we got to D here, now they tell you that the answer, the output is 17. You have to find the input. So I know that J of X is 17. That's why I put the 17 there. I got to try and find my x. So then I'm solving for x and working backwards, and you get x is equal to 4. So technically, you would say the j of 4 is equal to 17. Same with this one. When you solve it backwards, or when you undo to figure out what your x is, you get x is equal to negative 6. So technically, the answer is the h of negative 6 is equal to negative 2, because this is giving your output right here. And here, when there's an A, you just plug in the letter. Just like you did with the 10, you would plug in the letter, but I can't simplify it anymore. So G of A would equal negative 3A plus 1. So when we get down here and you're given the function notation, this is an equation. When I give you X values, you should be able to plug those in to this equation right here to find your f of X or Y values. Either way, this is a function. So I should be able to plug these in. When I plug in negative 2, 4 times negative 2 is negative 8. So 3 minus negative 8 is 11, and so on and so forth. Okay? When you go to then graph this, you double click, and it opens this window. And I believe I need to see what my table was. So I have negative 1, 7, and then 0, 3. So I'm going to go in here and I'm going to drag one of these. Now, negative 1, 7, that is a point right here. And I'm going to drop the circle. Then 0 comes first, and then 3. And then I believe it was 1 and negative 1. And then I believe the next one was 2 and negative 5, I think, because I'm going down 4, and then 4 and 4. Okay, so I should have a graph that looks like that. And then to grab my line, I dragged it down, but now I'm going to take this end. No. So I wait till I can get there. So now it's just a plain X, and that will kind of move it. And now I got to wait till I get the plain X, and I got to move that up here. And I got to keep going back and forth till I can get it to go through. There we go. I'm getting there. And there we go. Almost. So pretty close. And then I hit save and close. And there's your graph. Okay. I could have put 3, negative 9. That comes down here as well. So it's not quite, but that's how you should be graphing. Okay. You can go into Desmos and check to see if you did it right. I would also say here too, the biggest right down here, what's the connection between the input and the output? How are they related? Well, this right here, your equation is your relationship. Your equation is the function machine. Your equation is what's telling you this is the relationship between your input and your output. Okay? All right.